Hi everybody, I'm just going to record a really quick video about Physics 1 problems and exercises number 2, or sorry, test prep number 2. This one is really similar to number 1 and is made extra complicated to try to trick you. So it says, in an experiment, a student launches a ball with initial horizontal velocity, which it doesn't tell us what is, at an elevation 2 meters above the ground. So we're saying that if this is 2 meters, this is where we're starting from. And then it says it follows a parabolic trajectory until it hits the ground. So it's going to go start here, and then it's going to go whoo, and then it's going to go back down and hit the ground. So normally on a problem like this, that part, that starting above and then going down until it hits the ground would be really important. Here, it's actually not, and I'll tell you why in just a second. Then it says, which of the following would accurately represent the graph of the ball's vertical acceleration versus time? So we're looking at vertical acceleration again. So right, this is our acceleration on our y-axis. And so the whole time, the vertical acceleration is going to be towards Earth, and it's going to be 9.8 meters per second squared, because the Earth is going to be acting on this object the exact same way the whole time. So we look at our answer choices and we say, A, a negative value that does not change with time. Let's look at what that would look like. So this is going to be acceleration versus time. And if we do what our graph would be, so this is 9.8 going down, so that'd be negative 9.8. So if I make that right here, so I say like 3, 6, 9, and 9.8 would be maybe like here. Negative, negative, negative. We would just go like that the whole time, right? So that one sounds pretty good, letter A. Let's look at the other ones. A gradually increasing negative value. So that would be something like this. Well, that would mean that the acceleration is changing, which we know it's not. An increasing rate of negative values over time in a parabolic curve. So I suppose that would be something like that. But stopping there, I've got my cool erasable pen today, so I can fix that. We know it's not that, right? Because that would mean that acceleration is changing, and 0 at all times since the initial motion is horizontal. Well, it is horizontal, but since it's 2 meters above the ground, oh, whoops, that's not how I wrote it, is it? So it would be like that, actually. But the reason why it hits the ground is because it's being pulled down towards the ground. So we don't have any horizontal acceleration, but if we're above the ground, we have vertical acceleration, right? The Earth is going to exert a force on an object and pull it down until it hits the surface, and then it's going to continue to exert a force on it, but that's not going to cause any motion. Since the initial motion is horizontal, so that would mean that it looks like this, and that's not true because acceleration from the Earth is happening on all objects within the Earth's gravitational field all the time. So that can't be the answer either. So the answer for this one is this line right here, which is answer choice A. I hope this helps. Thanks.